All right, 4Cs, here is a little video introduction to hydrocarbons. Today we're going to talk about how to name alkanes, alkenes, and alkynes, and exactly what are those things. We're starting fresh here with our new unit in organic chemistry. So what is a hydrocarbon? The introduction is in the name. So hydrocarbon. In hydro, we're talking about hydrogen. Carbons, we're talking about carbon. So these are compounds that have both hydrogen and carbon within them. Now, the neat thing about carbon is it's got 4 valence shell electrons, so it can easily form bonds at 4 different locations with different atoms. Again, that atom could be another carbon atom, it could be a hydrogen, could be an oxygen, could be any of the halogen groups, so fluorine, chlorine, bromine, iodine, etc. So we've got a lot of options with carbon. This is why organic compounds are made out of carbon. Carbon has a lot of options with regards to bonding. Another one of the things here is, again, we're going to have hydrogens basically filling up all of the carbon atoms. So one of the more common families we're going to talk about here today is all these carbon atoms bonded to each other end to end. There's like a chain of carbons, and they're going to have hydrogen atoms bonded at all the other locations. So the key part to know is that carbon wants to bond with 4 things. So when you see a C, you want to make sure that it's bonded to 4 things. That could be another carbon, could be hydrogens. So again, what these compounds are known as is hydrocarbons. They are made up of carbon and hydrogen atoms. Okay, so here's some examples. Now, this looks more complicated than it needs to be. The top diagram shows all of the electrons that are in the compound. So for simplicity's sake, I've taken all of the bonds. And again, remember, bonds are represented by 2 electrons. These are covalent bonds. Most of them are polar covalent. Some of them between the 2 carbons are pure covalent or non-polar covalent bonds. But you can see down at the bottom, for simplicity, we're just representing the valence electrons as sticks. Okay, so each one of these sticks represents 2 electrons. And you can see if I take a look at every carbon, there's 4 bonds on every carbon. And that's the key part here when we want to have 4 bonds. So again, if I've got this scenario here, this is what is part of a family of chemical compounds called alkanes. And alkanes are characterized by single bonds. You can see that every single one of these carbons in this chain, it's a really long chain, but every single one of them is connected together by just a single bond. So this carbon is singly bonded to this carbon is singly bonded to the next, and so on and so forth. Okay, these are an alkane. So this is an alkane compound. So we've got another alkane, or not alkane, I should say. We've got another hydrocarbon here. And you can see the difference between this one and the one in the previous slide is now we've got a double bond formed. So this is a double bond. There's 3 carbons in the chain, and there's a double bond here between carbon 1 and carbon 2. This is called an alkene. Okay, so if some of the carbon atoms are held together by double bonds, they're classified as an alkene. And notice I've highlighted the E in alkene, and you'll see why in a second here. This compound, again, has got a name that it's an alkene name. So again, some carbon atoms are held together by triple bonds, and these are classified as alkynes. Alkynes, again, I've kind of highlighted the Y, and here's an example here. Here's a triple bond between these 2 carbons. And you can see, well, it's in the carbon structure. We'll talk about how to name this in a sec, but you can see that this carbon long chain, 1, 2, 3, 4, 5 carbons long, and every single one of these carbons is bonded to 4 things. This one's bonded to 3 hydrogens and 1 carbon. This carbon is only bonded to carbons. It's bonded to this carbon through a single bond, and it's bonded to this carbon with a triple bond. So there's 6 electrons being shared between these 2 there. So how to name hydrocarbons, alkanes, alkenes, and alkynes. I want you to stop and think. Take a look at these 3 diagrams here. What is the same about these chemical models and what is different? Pause the video. I'll give you a little second here. What's the same and what is different? Okay, so you've looked at these compounds. What is the same? Well, the same is each one of them has 2 carbons in them. So these each have 2 carbons. The difference is the type of bond between the carbon. This has a single bond, so this is an alkane. This has a double bond, so this is an alkene. And this has a triple bond, so this is an alkyne. How we name these is very similar, though. The only thing that we use is the difference between them. Because the single, double, and triple bond, that also changes the number of hydrogens that are bonded to the carbons as well. You can see this carbon and hydrocarbon has got 6 hydrogens. This one's got 4 hydrogens, and this one just has 2. So it changes the number of hydrogens in the compound as well. So All of the naming that we're going to talk about is set out by the International Union of Pure and Applied Chemists. You'll see this it's an acronym, IUPAC, or IUPAC is just short for all these people who got together and talk about the names of these things. Now, how we name hydrocarbons is pretty straightforward. We always use a prefix to indicate the number of carbon. And then the suffix is used to indicate the chemical family. Is it got single bonds, so is it an alkane? Is it got double bonds, is it an alkene? Or does it have triple bonds, is it an alkyne? Prefixes, pre means before, so that goes first. Suffix means after, so it's the last part of the name. So if we take a look at all of the prefixes, notice the color code here. If I've got 1 carbon in the chain, the prefix is meth. 2 carbons is eth. 3 prop. 4 but. 5 pent. 6 hex. 7 hept. 8 oct. 9 non. 10 dec. And then it goes on from there. But we're only really going to go up to 10 carbons in the long chain. Here's an example. So if I have a structure and it's called pentane, notice the 2 different colors. The pent means that there's 5 carbons. The anes means all single bonds. So if I were to draw this out, here's what pentane would look like. I've got 5 carbons in a row, and they're all singly bonded to one another. And then I make sure that all the carbons are bonded to 4 things. I fill up all the remaining spots with hydrogens. So I've got 5 carbons, and the hydrogens, if you counted them all, would actually follow a general formula. That general formula is this. So the formula is C5H12. For alkanes, the general formula is this. For the amount of carbons that we have, we double the amount of hydrogens, so 2N, and we add 2. This adding 2 comes from these hydrogens on the N carbons here. So again, if we've got C5, we doubled 5, so 10 plus 2 is 12. That's where we get H12. So pentane has got a molecular formula of C5H12. Here's the ball and stick model. If we were in class, we'd be looking at these model kits. But here's a ball and stick model of pentane, where the big circles here are all the carbons, the 5 carbons in the single bond. And we've got every carbon attached with some hydrogens. Some have 2, some have 3. Again, they just want to be bonded to 4 things. That's the key point of today. Here's some structural diagrams and molecular formulas of common alkanes. So methane means 1 carbon, ethane means 2, so there's 2 carbons singly bonded. Propane, what we burn, some people burn for barbecues, has got 3 carbons in a single, in a chain, and it's got all single bonds between them. All the formulas are there. Again, if I had butane, I would have 4, pentane, I'd have 5, etc., etc., 6. There's hexane, heptane, we could have octane and nonane, we could even have decane. Okay, so all of these are alkanes, single bonded hydrocarbons. There's decane here. Again, these are all carbon skeleton diagrams. So we can sometimes if you go online, you'll see that we're really just concerned about this carbon skeleton, that's just assume that the hydrogens are all bonded to the carbons. So sometimes people leave those off. So again, it's important to know here is hexane, 6 carbons, all singly bonded. And you would just assume that all of these would be bonded with hydrogens up, down, and making sure that there's always 4 bonds. Now, in actuality, you can see that this hexane isn't actually a long horizontal chain like this. It can actually form kind of bends and kinks. Again, it just depends on the bond type. It's kind of past what we need to talk about. But if just to say that this is exactly the same as this structure here. They both have 6 carbons, all singly bonded. So both of these represent hexane. So again, if the beginning of an 8 carbon chain, the carbon, if I've got a carbon central one here, I could put a carbon up top, I could put a carbon to the left, to the right, or down low. This can lead to a lot of different 2-dimensional drawings. Now we're going to be using this moleview.org to show kind of our molecules. And in that, if you clean up the structure, it gives you kind of the best electronically stable structure. So here's some possible structures for octane if you were just to draw this by hand. Notice all of these have 8, so octane, 8 carbons in the longest chain, and ane. They're all connected by a single bond. So this has 8, this has 8, this has 8, and this one has 8 as well. So again, all of these have the exact same chemical formula. They all have the exact same chemical and physical properties. All of these are octane, okay? Alkenes. So we change up our talk from alkane, single bonds, into alkene. So some hydrocarbons have double bonds, and these are alkenes. So with alkenes, what we do, how to name these, is we still use the same prefix to identify how many carbons are in the chain, but then we just change the ending to ENE. There's a little bit more complications to this, and we'll talk about this in a second here. Both of these carbons, when we take out some hydrogens to form the double bond, you can see we kind of took out some hydrogens here. We formed a double bond here. Notice that this reduces the number of hydrogens. You can blatantly see that there's 2 less hydrogens in this structure down below than it is up at the top. So the general formula for alkenes changes. It's no longer CnH2n plus 2. It's now just CnH2n. So to figure out the formula, we just take the number of carbons and double it, and that's our number of hydrogens. Okay, pretty straightforward stuff. So notice all of these formulas here. The number of hydrogens is always double the amount of carbons. So I have carbons 2, hydrogens 4, carbons 3, hydrogen 6, always double. So ethene, eth means 2, ene means there's a double bond. So I've got 2 carbons that are bonded together in a double bond. There is ethene. Propene, exact same sort of thing. We've got 3 carbons and we've got a double bond. Now you might be asking, does it matter whether the double bond is here or the double bond is there? What I would suggest you do is just take this and flip it upside down, or do a little horizontal flip, and you'll see they're the exact same formula. So if you flip that one upside down, they would have the exact same number. So propene is just propene. It gets a little bit interesting when we talk about 4 carbons. So butene, we can have a double bond here, or we could have a double bond between the 2 middle ones. This lays into the fact that we need a special name for this butene. So here it is here. So notice when the carbon chain reaches a length of 4 carbons, the double bond can be placed between the end carbons or the middle carbons, as we just talked about. Each of these structures is a different hydrocarbon. They actually have different chemical and physical properties. The top one is called 1-butene. So notice here, if I number the carbons 1, 2, 3, 4, the double bond exists between carbon 1 and carbon 2. So we choose the lower number here and we say what it is. So the double bond is at 1-butene. So 1 meaning where the double bond is, but meaning 4, and E meaning that double bond. This bottom one here, if we put the double bond in between the 2 middle carbons, this is between carbon 2 and 3. So the bottom one is called 2-butene. And again, this naming method numbers the carbon skeleton chain in a way that encounters the lowest possible number. So again, we would never have, if we put a double bond in between these 2 here, we wouldn't have 3-butene, because we could actually number this 1, 2, 3, 4. We're just choosing to number it from left to right. We can number it from right to left. It doesn't matter. Again, we always want to have the lowest possible number though. Okay. So how many different pentenes are there? I'm going to take you, I would suggest that you pause the video for a sec and try on just a sheet of paper to draw some of these. I'm going to give you the answer here in a sec. But pentene, remember, pent means 5, ene means a double bond. So where can the double bonds go? Pause the video now, try that question out for me. Okay, hopefully you got back to some questions here. Here are the different pentenes. So here's a pentene here. Again, 5 carbons. We've got a double bond there between carbon 1 and carbon 2. We have that as being 1-pentene, the double bond in between carbon 1 and carbon 2. We can shift the double bond to here. So this is between carbon 2 and 3. So this is 2-pentene. Now, on your sheet, you might just be shuffling this double bond. So the next option is to go from this double bond to here. If you were to do that, you might have drawn something and called it 3-pentene. But if you notice, 3-pentene and 2-pentene are actually the same. If we just numbered this 1, 2, 3, we would use the lower number here. 3-pentene is the same as 2-pentene, so we use the lower number, and there is no such thing as 3-pentene. 3-pentene is actually 2-pentene. So how many different pentenes are there? The answer is 2. 1-pentene and 2-pentene. All right, this is where it gets a little crazy. This is going to take you a little bit of time, but I want you to continue doing what we just did. I want you to draw all the possible hexenes, heptenes, octenes, nonenes, and dekenes. Okay, so hexenes, we've got 6 carbons in the chain, heptenes 7, oct 8, nonenes 9, and dekenes 10. Pause the video, come back when you're ready. There is a lot of compounds here. All right, hopefully that didn't take you too long. Here are all the different possibilities. And the list just goes on and on and on. You can see there is a little bit of a pattern to all of these things. But again, we're always numbering these. The double bond always is communicated using the lowest possible number. Okay, so here's all of the options of compounds. Now, alkenes can also have multiple double bonds. If they do this, they're called a diene. Di meaning two, ene meaning double bond. There are trienes. So 3 double bonds would be a triene. 4 double bonds is a tetraene. Tetra meaning 4. So if we had a diagram for propadiene, take a look at this name. The prefix is prop. So that gives us an indication of how many carbons are in the long chain. Prop means 3. Diene means 2 double bonds. So propadiene's got 3 carbons in the chain, and there's 2 double bonds. So there it is right there. There's no other options for propadiene. We don't need numbers or anything in front of it. What about this? So what is the name of this? I've purposely left off all of the hydrogens just to make this as simple as possible. The first step in all of this is to count how many carbons are in the chain. So let's do that. 1, 2, 3, 4, 5, 6, 7, 8. So this is oct, right? So the prefix for 8 carbons is oct. So this is a oct, and you can see we've got double bonds, so this is a ene. Now, how many double bonds do we have? We have 1, 2, 3. So this is a triene. So this is octatriene. Now, where are the double bonds? We have to number these so that the numbers are the lowest possible combination. So we can number this, start with a 1 here, 2, 3, 4, 5, 6, 7, 8, or we can do it the opposite, 1, 2, 3, 4, 5, 6, 7, 8. So that gives us 2 possible combinations. So is this 3, 4, 7 octatriene or 1, 4, 5? Well, the answer is in adding up all of these numbers. Whatever one has the lowest number combination is the name. So this one is 1, 4, 5 octatriene, right? So which numbers add up to the lowest total? And that is the 1, 4, 5 octatriene. Okay, alkynes, triple bonds. Again, some hydrocarbons have triple bonds. Again, carbon won't form 4 bonds, but this is the maximum number it can. There's some reasons why you'll learn about that in future chemistry courses. Now, alkynes end in YNE. So very much like how alkanes ended in ANE, alkenes end in ENE, alkynes, triple bonds, end in YNE. So here is just continuing on with what we were talking about. 2-pentyne. The pent tells you how many carbons are in the long chain or the parent chain. So we've got 5 carbons. And where's the double bond? The double bond's at triple bond. Where's the triple bond? It's at carbon 2. So 2-pentyne talks about the fact that the triple bond is in between carbon 2 and carbon 3. Here is 2-pentyne. Now notice I flipped this from maybe what you were expecting. Again, I numbered this carbon 1, this carbon 2, this carbon 3. Again, our numbering system doesn't matter whether we go from right to left or left to right. In this case here, I numbered this one, 1, 2, and there's my triple bond. Notice the formula for pentynes, for 2-pentyne in here, changes. So again, the carbon chain can be numbered from left to right or right to left, as long as the lowest possible numbered carbon begins with the triple bond. What would the general formula be for this? Well, if we found this out, this is C5, and if you count up all the H's, we got 1, 2, 3, 4, 5, 6, 7, 8. C5H8. So the general formula for alkynes, actually, we've just, by making this triple bond, we've eliminated 2 more hydrogens. So it is the general formula is CN and then H2N take away 2. We've taken away more hydrogens. So there's the general formula down in the lower left-hand corner. And there we go for alkanes. And I think that's the end of our note. Try right now. There's an activity for you to do. You can be using moleview.org to help you go through all this stuff. Hopefully you've learned something from there, and we'll see you soon. Bye.